So this video is a continuation of Chapter 4, Lessons 1 and 2. And in this video we will take a look at the problems from the PowerPoint, the problems where you needed to do out some work that apply the theorems that we talked about in the last video. If you have not already tried those problems, please pause the video, go ahead and try all the problems from the slides. And once you're ready, then restart the video and we'll go through the results. So if you are looking at the results here, I will assume that you have finished those problems and are ready to check them. So the first few slides use the idea behind the triangle sum theorem that the sum of the measures of the three angles of a triangle is 180 degrees. So in this case here we're looking to use the diagram to find the measures of angles XYZ as well as angles YWZ. And those two angle measures, XYZ, should be 78 degrees, and the measure of angle YWZ should turn out to be 50 degrees. In the diagram here, we're looking to find the measure of angle MJK. It's a little hard in the diagram on your printout to see the measure of angle MJK, to see where MJK is. And in particular, it's hard to see that the two angles in red on this diagram that are tick marked as congruent are actually congruent. So angles JMK and angles MKN are actually tick marked here as congruent. So you may not have noticed that in your handout. But using that information and the angle sums of the triangles, that will allow us to figure out the measure of angle MJK to be 32 degrees. And now we're going to use the corollaries that we talked about. The acute angles of a right triangle are complementary, and the measure of each angle of an equiangular triangle is 60 degrees. So in this case here, one of the two acute angles in a right triangle has a measure of 2x. The other angle, whoops, here come the words. The measure of the other acute angle is going to have to be 90 minus 2x. One of the acute angles in a right triangle is 63.7 degrees. The other angle, again here come the letters a little slowly. The measure of the other acute angle in the right triangle is going to have to be 26.3 degrees. And here's another use of it here. One angle in a right triangle, one of the acute angles in a right triangle has a measure of 48 2/5 degrees, which means the other acute angle is going to have a measure of the difference between 90 and 48 2/5, which is 41 3/5 degrees. Now we have a couple of applications of the exterior angle theorem. In this case here, angle BCD is an exterior angle of the triangle since it's formed by one side of the triangle, segment BC, and the extension of side AC. So its measure, using the exterior angle theorem, should be equal to the measures of its two remote interior angles, which are the angles at B and A. So that's where our equation for this one is going to come from. So once we have the algebraic equation set up, solving for the value for x gives us x equal to 26. And to find the measure of angle B, we're going to take that value for x and plug it in to find the measure of angle B to be 55 degrees. Here's another application of the exterior angle theorem. We have a right triangle ABC. We have an exterior angle, angle ACD. And so the measure of angle ACD is going to be equal to the measures of angles A and B added together. So the algebraic equation that we're going to write to go along with this one will say 6z minus 9 is equal to the sum of 2z plus 1 and 90. Solving for the value for z is going to give us z equal to 25. And to find the measure of angle ACD, I'm going to plug 25 into the measure of 6z minus 9 to end up with 141 degrees for the measure of the exterior angle ACD. Now we have a couple of uses of the third angles theorem. In this diagram here, we have two triangles that overlap. They have tick marks at angles F and I. Those two angles are congruent. They have tick marks at angles G and H. Those two angles are congruent, which means then by the third angles theorem that angles K and J must be congruent. So if those two angles are congruent, their measures are equal. So I can substitute in 4y squared equal to 6y squared minus 40 to end up with y squared equal to 20. Now you may take that a step further and find y to be 2 square roots of 5. But if I want to plug that back in to find the measures of k and j, I'm going to end up just squaring the y value again, so the measure of k turns out to be 80 degrees, and so will the measure of j. Okay, another application of the third angles theorem. Again, we have two triangles with two angles that are marked as congruent, which means the third angles P and T are going to need to be congruent. So the measures of P and T will be equal. Substituting in and solving for the value for x is going to give us x squared equal to 16, so x equal to plus or minus 4. However, again, if I'm looking for the measures of the angles, I'd only have to turn around and square those values, so the measures of both P and T are both 32 degrees. And our final couple of examples here, for number 1, the answer to that one is going to be 33 1/3 degrees, because the two acute angles need to add up to 90 degrees. In number 2, the measure of angle ABD should turn out to be 124 degrees. Your equation should have said 2x plus 16 is equal to 58 plus x plus 12, using the exterior angle theorem for the triangle. And in number 3, the measures of the measures of N and P are both 75 degrees, and that comes from the third angles theorem. Angles M and Q are given to us as congruent, as are O and R, which means angles N and P are congruent. Set their measures equal, solve for the value for x. Once we have the value for x as plus or minus 5, plug it back in, and we end up with both angles N and P being 75-degree angles. So, in class tomorrow, you will be working on some problems from the textbook and some supplemental problems, perhaps, that deal with classifying triangles as well as working with triangle sums.